Good day, everyone. Today I will be presenting an overview of Eurocode load combinations based on European Code EN 1990 and 1998. In structural engineering, we do not consider the load acting on the building itself, but rather we always consider the combinations of actions such as dead load, live loads, wind load, earthquake, and so on. Actually, in all standard, they have their own ways of defining the load combinations, but in my case, I do prefer the Eurocode because of one very important characteristic of it comparing to others. The Eurocode, it reflects the realistic conditions by recognizing that not all the loads reach the maximum simultaneously. It consider one dominant load while reducing the other based on the probability, because if you consider on other standards, they will have something like maybe 1.4, and then 10 dead load, and then 1.6 maybe for live loads. But, I mean, what does this means? If the fact is taken fools, it means you assumes all the loads they occur at the same time in a full capacity, which is something that is very rare to happen. But for the case of Eurocode, they consider that thing. That's why they have scenarios they develop, which make me see it as one of the essential combination that can be used in the realistic structure design. According to the Eurocodes, the load combinations can be defined by using three types of actions loads. We have the permanent action loads that is always presented by a letter G, which include the self-weight, finishes, superimposed dead loads. Also, we have variable load, or variable actions, which is presented by a LQ, which include all the live loads, wind lots, snow lots, all kind of lots that is varying. And also there is accident actions load, which most of times is like explosion load, is the kind of load that have been ignored mostly in the yielding constructions, but yeah, in the Eurocode it have been included, so we have to include it also in the design when we are doing the design. In this whole concept of the load combination in the Eurocode, it can be explained by using these fundamental questions. This is the fundamental equation that's used to derive all the load cases in. It's referred from the European 1990 question 6.9a. In this equation, we see different terms, GK, which stand for the dead load, or dead action loads, like I explained earlier. QK, this is where this is standard differ from other standards, because these terms QK plus 1, it means the leading variables where the factor of safety, it's taken as full values. This one is also the terms for all other varying load, but in this case we treat them as accompanying loads where the factor of safety will be reduced by using C naught, this one. YG, gamma G, and gamma Q, these are the partial factor of safety. For gamma Q, it's always 1.5. We will see a little bit on the next step. But for IG, it's always differ depending on the conditions, because there is two conditions defined by the Eurocode. The first one is unfavorable and the second one is favorable. If it's unfavorable, we always use 1/35 for the cases where they self-weight, it's affecting something like the bending moment, but if you are starting something like compression where the dead load, it's increasing the compression and making the structure more stable, at this case, we always use the factor of safety. It will be just 1. In Eurocode, as limited state, as it's always defined in other courts, we already know is the condition beyond which the structure has no longer satisfied the safety and usability requirement. When we say safety, we mean the ultimate limited state, while the usabilities safest limited state, which is dealing with comfort and proper functioning of your structure. The limited state in Eurocode, it can be defined from the general equation. Actually, we can extract all these equations which can be used to generate all the load cases. For ultimate limit state, we have these equations where YG, as I explained earlier, can be 1.35 for unfavorable conditions, or it can be 1. It's depending on which condition, which cases are you developing. This is the dead load. This gamma Q, it's always 3.5, as I explained earlier. This is the leading varying load. It can be anything. It be live loads. It can be wind, long axis leading at that moment where you treat other varying load as accompanying, which this factor will still remain 1.5, but to reduce it so that because this term is not for main load, it's for accompanying loads. That's why this factor will be reduced by multiplying with this C note. The value for C note I will share later. Then for the case of service load, it's always defined in three cases. There is rare, or sometimes we call it characteristic, and then there is frequent, which is the condition where, normally happen. And then we have cause permanent, which is the condition of a long period of time. For the case of rare, all these loads, if you check well, they are same with this equation except that the factor gamma, gamma g, and gamma q have been ignored because the load will be taken as full the way it is. There is no way to amplify it because at this case we are just checking the structure of the building in the real conditions. But the main difference you can notice within the three cases is these factors C0, C1, and C2. So this one is defined depending on whether it's rare, frequent, or cause. This is the table A11 from the Europe of 1990. It's defined different values of 5.0, 5.1, and 5.2 depending on the structure that have been designed. For example, for the case of residential building, there is 0.7, 0.5, and 0.3. So this equation will be plugged. These factors, depending on your structure, will be plugged on this equation so that you can get exactly the load combination that you can use for your structure design. Different cases can be developed, but I think after this video I will make another one to try to show in Excel. And I will share the Excel too so that you can see example how we can generate the load cases is from all these equations. So technically the key principles of this whole combination is the permanent load is always included. That is the key things to take. For the variable load, there is only one variable load. It can be life, it can be wind load, it can be anything. And other loads will be reduced by the factor C, as I explained before, based on the table. The Eurocode, in this case, it's always ensure the realistic load combination, prevent of summations of simultaneous load, and also essential for safe and economic design. Thank you. That is all for today. I think on the next one, I will just show the real example by using a Excel sheet where we can, later on, we will transport the load combinations on the app so we can see how we can run our result. Thank you very much.